Hey friends, welcome to Unit 2 if you are following along with me at school. If you are following along with me from a different school, this may not be your Unit 2, but we are going to tackle radicals in this unit, and it's going to be so fun. Okay, so here's what we're going to do for the first couple of days. Today is just meant to kind of bring you back onto the same page of the concepts of radicals that we talked about in 10C. Now, if by the end of this lesson you are super stressed out, never my intent, but it may mean that you just want to have a little bit more of a refresher on simplifying radicals and writing radicals from mixed to entire and entire to mixed. Those are the concepts I'm going to deal with today. If you find them super stressful, you may just want to go back. I do have videos from 10C where I talk about these things much more in-depthly. And just in YouTube, you can just Google Peter Hill. I guess you don't Google it if you're in YouTube, but just search Peter Hill and Math 10C radicals, and a few lessons will pop up that you could use as just kind of a deeper review if you needed a deeper review, okay? My intent is at the end of this lesson, we are going to feel super, super confident about simplifying radicals and then writing mixed radicals as entire radicals as well. Along with just the concept of what a radical is and why we would use it, okay? That's our goal. Tomorrow, we're going to start focusing in on mathematical operations. So we're going to tackle addition and subtraction, then we're going to tackle multiplication as one lesson, and then we're going to tackle division as one lesson. And then we'll throw some letters and variables in there, and we get to talk about fun things like restrictions and yeah, it's a fun unit, okay? It's a fun unit. We'll have lots and lots of time to review together, to make sure we understand together, and to make sure we make 100 on our test, okay? That's the goal. Okay, so let's get going here. I am just going to hide myself for just 1 sec so I can read that to you. In this unit, we will learn how to add, subtract, multiply, divide, and simplify radical expressions. Okay, so some basic radical rules and definitions first. The result of squaring an integer is called a perfect square. Okay, so 4, for example, if I squared 4, I get to 16. 16 is a perfect square because we know its square root. We know its square root is 4. Okay, the square root of 16 is 4. Now, that doesn't mean to be a perfect square, your square root has to be an integer. It just has to be a terminating decimal, okay? So for instance, if I had given you, hey, what's the square root of 9 over 4? 9 over 4 is still considered a perfect square. The square root of 9 over 4 is 3 over 2. That is something we know. Okay, that's not an irrational number. We're good to go. That's just 1.5 if I was thinking about that as a decimal, okay? So a square root, a perfect square will have its square root as something that is rational, something that is known to us, okay? Okay, and on the same breath, the result of cubing an integer is a perfect cube. And then again, when we go the other way, the inverse operation of cubing a number is called taking a cube root, okay? Now, this is something you want to get super, super familiar with. This picture right here, okay? I'm just going to hide myself so you can see the words there for a sec. That whole thing is called a radical, okay? Now, we have that little n and that x. The little n is called the root index. And sorry, I'm trying to press buttons and talk at the same time. The root index, and then the x portion, the thing that's underneath the radical, is called the radicand with a D. Okay, really important if you are writing a root index that you do it as a small number inside that little check mark symbol. Okay, for instance, if you did this very messily, like that, I'm not sure whether you mean 3 times the square root of 3 or whether you mean the cube root of 3. Okay, so make sure you are very, very clear in how you're writing. Okay, now my writing's a little messy because I'm writing with a mouse, but you can get my drift here. Okay. Now, if we're talking about a square root, we don't write the 2, but any other root, cube root, 5th root, 10th root, 18 millionth root, we would have to write that root index in. Okay. But if it's a square root, because we use square roots so much, nothing there is understood to be a 2. Okay. So again, I'll just hide myself for just 1 sec so you can see those words. If you express an answer as a radical, the answer will be exact. Now, exact means there's no rounding error, okay? If you all go in your calculator and hit root 2, okay, you're gonna get like 1.41 and some change, but you get this long string of decimal numbers, okay? No matter where you stop that number, say you stop at the 2nd decimal or the 5th decimal or the 10th decimal, it's no longer an exact value because that number actually goes on forever. The only way to actually write it without a rounding error is to just keep it as root 2, okay? So if you write a radical in decimal form, the answer will be an approximation. Now, an exception to this is when the radicand is a perfect square or cube, right? Because we actually know that that will be a terminating decimal. Okay. All right. So now we're going to talk about radicals as far as 2 different forms. We can write them in entire radical form or mixed radical form. So an entire radical has a coefficient that is 1. For example, root 20. Okay. A mixed radical, on the other hand, has a coefficient that's not 1. For example, 2 root 5. Okay, now mixed and entire radicals are different forms of each other. Now, just to show you that, go grab your calculator and go root 20 in your calculator. And then go and do 2 root 5 in your calculator. And you will notice that you're looking at the exact same number. It's the exact same string of decimals. Okay. They are the same number, just 2 different forms of each other. This would be analogous if I take you back to junior high and we pick on this 3/2 for a second. In junior high, you would have called that an improper fraction because the top was smaller than the bottom, or the numerator was larger than the denominator. Okay. We could also write 3/2 as 1 and 1/2. So here's an improper fraction. Here's a mixed number. Okay. They mean the same thing though. If I type that in my calculator, no matter what, it's going to be 1.5. Okay. So 3/2 and 1 and 1/2 are 2 different forms of the same number, just like root 20 and 2 root 5 are 2 different forms of the same number. Okay. So where we're going today is we need to try and convert between these 2 forms. Okay. Now that was a 10C concept. That's what we want to just review today. Okay. Okay. So I'm going to walk you through 2 different ways to do simplifying radicals. Now, when we simplify radicals, we're trying to get the radicand as small as possible. Okay. That's the goal. The 2 methods I'm going to talk to you about are prime factorization and then just looking for perfect square factors. Okay. I personally prefer the second one. I don't do prime factorization myself much because I find it just a long process. But that being said, if you do it and you like it and you are always getting the right answer, please keep doing it, okay? That's why I'm going to review it with you right now. So prime factorization involves using prime factorization of the radicand, okay? So remember that a prime number is a number that can only be divided by 1 and itself. Okay, so if I showed you root 20, what we want to do is break root 20 down into its prime factors. So I could go 2 times 10 or 4 times 5, doesn't matter. The 2 is prime, so I can just leave him there. Then I could go 10 is 5 times 2, and then those are both prime. So what I'm going to do there is I've got 2 times 2 times 5. So I'm going to rewrite root 20 as root 2 times 2 times 5. Now I'm looking for pairs of numbers. Every pair that I get is actually a perfect square, which means it can come out and be one of those numbers instead. Okay, so a pair of 2s can come out to be 1, 2, and then I'd be left with root 5. Okay, so we have used prime factorization to say that root 20 and 2 root 5 have to be the same thing. Okay, and again, how could you check? You could just throw root 20 in your calculator, throw 2 root 5 in your calculator, and they would say the same thing. Okay. All right, let's try root 108. Again, we're going to prime factorize. So we're going to break it down into its prime factors. So I went with 9 times 12 first. You might have gone with 36 times 3, or you might have gone with 2 times 54. It doesn't matter, okay? You'll get to the same answer as me regardless. Now the 12, I break down into 4 and 3, and then the 4 goes into 2 and 2. And then I'm going to go back up to this 9 and break that down to 3 and 3. So I end up with 2 times 2 times 3 times 3 times 3, okay? So I rewrite root 108 as the root of 2 times 2 times 3 times 3 times 3. Now I'm looking for the pairs. So that pair of 2 can come out. So that would be 1, 2. A pair of 3s can come out. So that would be 1, 3. And those are going to get multiplied by each other. Okay. And so I'd end up with 6, 2 times 3, with the root 3 there. Okay. Perfect. Okay. Now you try this one. 2 root 288. Now, before you try this one, I'm just going to warn you, a common mistake that kids make is they take this 2 and put it in right away. You don't need to do that, okay? Nobody asks you to write as an entire radical. What they're asking you to do is to simplify. To simplify, you need to make this number as small as possible. Okay, so let's do that. I'm going to take 288 and I'm going to break it down into prime factors, okay? Pause me and try that yourself. Okay, you should have had, notice I kept my 2 out there. 2 times 2 times 2 times 2 times 2 times 3 times 3. So essentially, 5 2s and 2 3s there. Okay, and so now I'm looking for pairs. So I've got a pair here of 2s that can come out. I got another pair of 2s here, and I got a pair of 3s. So that's going to be the 2 that was originally out there. And then I'm going to bring out 2 more 2s, because I've got 2 pairs there, and then a pair of 3 that comes out as 1, 3, right? Because if I'm taking the square root, it'll just be one of those instead. And then I'd be left with a root 2 in the radicand, okay? 2 times 2 times 2 is 8, times 3 is 24. So I end up with 24 root 2. 24 root 2, okay? Awesome. See, we can do this. This is great. Okay, then cubed root of 48. Same conversation. I'm still going to break it down into prime factors. The difference here is I need to find sets of 3 that will come out to be 1. Okay, because now I'm looking at cube roots instead of square roots. So the cubed root of 48 breaks down into 2 times 2 times 2 times 2 times 3. And then I've got 1 set of 3 here that can come out to be a 2. That was a really bad 2. And then what am I left with? 2 times 3, so that'll be 6. Okay. Don't forget your cube root there. Super important. Okay. All right, now we're going to look at the one I tend to use more often, which is dividing by perfect factors. So either perfect squares or perfect cubes, okay? So this method involves the multiplication property of radicals. Really, the other one did as well, but the multiplication property of radicals says the nth root of a times b will be the nth root of a times the nth root of b. So if I have multiples inside here, I can split them up to be separate statements, each underneath their own radical with the same root index, okay? Now, helpful for you to remember your perfect squares and your perfect cubes. I'm going to ignore 1 because factoring out a 1 doesn't do anything, okay? So the perfect squares I want you to be thinking of start at 2 squared, which would be 4, 4, 9, 16, 25, 36, 49, 64, 81, and 100. That's up to 10 times 10. And that's usually as much as you need to know. And then your list of perfect cubes, again, I'll ignore 1. So we'll start at 2 cubed, which is 8. We'll go 8, 27, 64, 125, and 216. Okay, so those are really, really helpful to commit to memory. And on a test, you want to just build those right at the top of your test so that you have that list that you can refer to at any point in time. Okay, all right, so we're going to do the same few examples that we started with. Root 20. Now, instead of prime factorizing, I'm looking for a perfect square factor of 20. I know 4 is a perfect square factor of 20. So I'm going to go, okay, root 4 times root 5 would be the same as root 20. Okay, so then I know, hey, the root of 4 is 2. So I have 2 root 5. Okay, so I split my 20 into 4 times 5, each underneath their own radical. And then I could just simplify the root 4 to be 2. Okay, root 108, I know that 36 times 3 is 108. You may not know that, and that's totally okay. You may go start with 9 times 12, or you may start with another one. Totally doesn't matter as long as you start with a perfect square, right? So the root of 36 is 6, and so I can change that to be 6 root 3. Now, just in case you're thinking, well, what if I had started something else? Well, let's talk about it. I like talking. If I had gone root 108 and said, oh, well, that's going to be root 9 times root 12. And then the root of 9 is 3. So that would have given me 3 root 12. Okay. You did this beautifully. You're just not done yet. 12 and then be 4 times 3. So then I would go 3 root 4 root 3. And then the root of 4 is 2. 2 times 3 is 6. I still end up with 6 root 3. Okay, everything is still the same. So even if it takes you another step, sometimes that's the easier road to do it because you're not dealing with numbers that are so big. Okay, so whatever makes sense for you, do that. Okay, 2 times root 288. I see the 288 as 144 times 2 right away, which I happen to know the root of 144 is 12. But again, if you didn't see that, that's totally okay. You can do it in a couple of steps. Okay. So I'm going to go 2 times root 144 times root 2. Root of 144 is 12. 12 times 2 is 24. So I end up with 24 root 2. Okay. The object of our game here is we want to make this number, the radicand, as small as possible when we're simplifying. Okay, that's what simplifying means. Okay, cubed root 48, nothing changes but the list. Okay, the process of what I'm doing of looking for those perfect factors is exactly the same. The difference is now I'm looking for perfect cubes, so I'm using my perfect cube list instead of my perfect square list. Okay, so I know that 48 is 8 times 6, so I go cube root of 8 times cube root of 6. Please, please, please remember not to drop your cube root signs. They need to be on both of those items, okay? Super important. Okay, and then the cube root of 8 is 2, so I've got 2 cube root 6, okay? Then I have, last example here, root 70. I'm back to looking for perfect squares. Well, I know 4 doesn't work. I know 9 doesn't work. 16 doesn't work. 25 doesn't work. 36 doesn't work. Okay, and how do I know it doesn't work? Well, I'm just putting them in my calculator and seeing if they give me a factor that's clean, right? If they give me a bunch of decimals, I know it doesn't work. 49 doesn't work. 64 doesn't work. And like now I know nothing works, right? Because I'm already at 70. So this is already simplified. I can't do anything else to it. It is in the simplest form possible. Okay. All right, my friends, you guys are doing awesome. This isn't scary, right? Okay. Now we're going to go the other way. We're going to go from mixed to entire. Okay. To do that, this guy needs to get under a square root. So essentially I'm asking myself, okay, the root of what would give me still 2? Because I can't change the number, right? So I'm thinking to myself, okay, the root of 4 would give me 2. Now, if you can't see that in your head, that's okay. What you're doing is you're going to square it. so that when you put it under the square root, you'll get back to the original number, okay? Now that they're both radicals, I can multiply the radicands together. So I can go root 4 times root 5, and that'll give me root 20, okay? All right, with negative 6 root 3, same thing, except you can't bring the negative in because you can't take the square root of a negative number. So you can only bring the 6 in. So you're focused on the 6. You're asking yourself, okay, the square root of what is 6? And the answer to that would be 36. So you're going to go negative root 36 times root 2, and then you multiply the 36 and the 2 together. Sorry, I said 2. I meant 3. Root 36 times root 3. And then 36 times 3 is 108. Okay. My face was actually covering up the root 3 when I was talking. Okay. So negative root 108 would be your answer there. Only do this if specifically asked to. Usually when you're doing math, we don't express things as entire radicals. We want to express things in simplified form, which would be a mixed radical with the smallest radicand possible, okay? So you would only do this procedure if the question said, hey, write your answers as entire radicals, okay? Okay, 2 cubed root 3. Again, we're just trying to get that 2 to be a radical, but this time it needs to be the cube root of something, okay? So I'm thinking, okay, the cube root of something has to give me 2 so that I can multiply it by the cube root of 3. Well, if I'm unsure of that, I just need to cube the 3, or the 2, sorry. So the cube of 2 is 8. So the cube root of 8 is 2. So I haven't changed anything there, okay? But now I can go 8 times 3 and get the cube root of 24. Okay. Awesome. Now, negative 5 cubed root 2. Funny thing, I can bring the negative in if it's a cube root. Okay, I can take the cube root of a negative number. That is totally fine. So I'm going to cube negative 5 and I get negative 125. So I'm going to have the cube root of negative 125 times the cube root of 2. And then I can multiply those guys together and get the cube root of negative 250. Okay. And like everything we've been doing here, if you want to check that you've got the right answer, all you got to do is put the first number in your calculator, put your last number in your calculator, and you should be looking at the same string of decimals. Okay. Awesome. Okay, so let's summarize what we've talked about today. The simplest form of a radical is when it is expressed as a mixed radical. So that means we want the smallest radicand possible. So this is better than this, okay? You can express a radical in simplest form by using prime factorization. That was the first piece that I talked about, or by dividing the radicand by its perfect square or perfect cube factors and using the multiplication property. That was the second item I talked about, okay? An answer expressed as a radical is exact. Well, an answer expressed as a radical in decimal form would be approximate. Okay. Okay, awesome. So this was the review of 10C. If you're stressed right now, please don't be, okay? That's not my intent. But please take some time to go back and check out those 10C videos. That will go a little bit more in depth as to how to kind of go through these processes, okay? I've got your homework there for those of you who are with me at school. All of you though, make sure you're practicing lots and make sure you're coming in asking me lots of questions, okay? And then I'll see you tomorrow for adding and subtracting. It'll be super cool. Take care, guys. You got this.